Unit 16, Day 2, factoring with a equal to 1. Now, what do we mean by a equal to 1? Now, the main thing is that we're going to be dealing with things of the form ax squared plus bx plus c. What we mean is when this number right here is a 1, or rather there is no number in front of that leading variable. Alright, now, on number 1, I want to go ahead and and touch on what Mr. Melton talked about yesterday with the factoring by grouping. So what we do is we do 1 times 12, as we know, and that's 12. And then that's going to be 1 and 12, 2 and 6, 3 and 4. Now, there's one set of those that are going to add to give me 8. And that's this one right here. Alright? So that means that we're going to go x squared plus 2x plus 6x plus 12. Alright, now we can factor by grouping. Go ahead and break apart our groups. And we got an x on the outside of x plus 2. And then we've got, let's see, 6 goes into both of those. So we got 6. And that's going to be x plus 2. So what our factors are left to be is x plus 6 and x plus 2. And there it is. Alright, now, let's see. If we look at number 2, we can do much the same thing. We say 8 factored, that's 1 and 8, 2 and 4. Alright, and that's going to be y squared plus y plus 8y plus 8. So we got y on the outside of y plus 1 plus 8y plus 1. They got y plus 8 and then y plus 1. Alright. We're going to do something, and we can do something very similar for number 3 as well. Okay. So we can go 6 broken apart, that's 1 and 6, 2 and 3. 2 and 3 combine for 5, right? So we can go v squared plus, oh, not plus, whoops, minus 2x minus 3x plus 6. Keep in mind, okay, that's a negative 5, okay? We need these to combine for negative 5. And then we're left with v squared minus 5x plus 6, right? If we were to combine them. Now, what we can do is we can go ahead and set up our groups right here and right here. So on this first one, I can pull out a v. That's going to be v minus 2. And then on the second one, I can pull out a negative 3. That's going to be v minus 2. So what I've got is v minus 3 on the outside of v minus 2. All right. Now, on number 4, I'm going to step things up just a smidge, okay? I'm going to go ahead and I'm going to show y'all something else. All right, so whenever I see the number 12, all right, I see 1 and 12, 2 and 6, 3 and 4. The only thing that will combine to give me 7 is 3 and 4. All right? Now, I know that everything's going to wind up looking like this today. Right? Everything has a leading coefficient of 1. So, I need to get negative 7. So, x minus 3 and x minus 4. And there we have it. Alright? Now, number 5. Let's see. If we do this one, negative 50, okay? We need two things that are going to subtract to give me give me 5 in some way, shape, or form. So I need 1 and 50, 2 and 25. Let's see, there's nothing for 3, nothing for 4, 5, and 10. Oh, there we go. That'll work. Alright, so that's going to be x squared minus 10x plus 5x minus 50. Alright, when I combine the 10x, when I combine that negative 10x and that positive 5x, that's going to give me negative 5x, right? So, I can go ahead and I can break this apart into two pieces, and I can go x on the outside of x minus 10, and then I can take a 5 out of the second piece, and I can go plus 5 and x minus 10. Now, I want y'all to notice something about this, okay? If you notice, we wind up with the same thing in each set of parentheses, the x minus 10 and the x minus 10. If you don't wind up with the same thing there, then you're doing something wrong. So we got x plus 5, and we got x minus 10. And there it is. All right? Now, next thing, number 6. X squared plus 3x plus 5. All right, if we come out here to the side, all right, we're going to look at 5. That's 1 and 5. There's no way for us to factor this nicely. At least not yet. Okay? Y'all don't quite have the tools for it. We'll work on it. This, for the time being, is what we're going to call prime. Okay? Alright, number 7. Alright, so we got w squared plus 9w minus 10. Alright, so, quick riddle. Okay? What can I multiply to get negative 10, but combine to get positive 9? Alright? And survey says plus 10, negative 1. Okay? So, when I add those, that equals 9. Okay? When I multiply them, that equals negative 10. Alright? So, what we say is w plus 10, w minus 1. And that's the answer. Okay? And you should be able to get faster and faster with these as time goes along. Alright? And number 8. Is there any way to get positive 1 out of the multiples of negative 2? Alright, so we got negative 2. We got 1 and negative 2. That wouldn't work. How about negative 1 times times positive 2? That might work. Okay? So we can do m squared minus m plus 2m minus 2. We go ahead and we break this apart, and we go m on the outside of m minus 1. And we're going to take a 2 out of the second piece here. We're going to go plus 2 there. And that's going to leave us with m minus 1 on the inside. So we got m plus 2 and m minus 1. And there we have it. Alright. Now, number 9. Okay. What will multiply to give me negative 12, but combine to give me 11? Alright. So, let's see. if I go, let's go with 12 times negative 1. That's going to equal negative 12. Okay, and if I do 12 minus 1, I get 11. Okay, that's what I'm looking for. So that means it's going to be u plus 12 and u minus 1, which equals, oh, we're not to that part yet. Alright. Alright, so next problem. We've got number 10. Okay? Alright, so on number 10, we've got g squared minus 7g minus 18. Now, what can combine to, or what can multiply to give me 18, but combine as in add or subtract to give me 7? Well, let's run through them real quick. We're going to have 18, that's 1, 18, 2, and 9, 3, and 6. I see a pair right there that's going to be useful to us, okay? Because 9 minus 2 is going to be 7. So what we have is we have g squared, and let's go with minus 9g plus 2g minus 18. Alright, now if we factor this out like we're supposed to, that's going to give us g on the outside of g minus 9. And then we're going to pull out a 2 on this other piece. It's going to give us g minus 9 here as well. So what we're left with is g plus 2 and g minus 9. And there we have it. Okay? Now, number 11. Okay? Let's run through the factors of 16 real quick. We're going to go 1 and 16, 2 and 8, and 4 and 4. So, let's see. If we do 1 and 16, 2, 8, 1 and 16, that's going to be 15 or 17. We're trying to hit 8. 2 and 8, that's going to be 10 or 6. Not 8. 4 and 4, that's going to be 8 or 0. We've got 8. Yay! Okay, so we've got m squared plus 4m plus 4m plus 16. Alright, and we're going to go ahead and draw our parentheses like that. And it's going to be m on the outside of m plus 4. And then we're going to go ahead and pull a plus 4 out here. And that's going to give us m plus 4. So that's going to be m plus 4 times m plus 4, which could also be written as m plus 4 squared. And there it is. That one's done. Now, moving along here. A dog's pin is rectangular in shape and has an area of x squared minus 5x minus 36. Find the length of the pin if the width is x minus 9 feet. Alright, so we've got x minus 9, and we know that there's going to be another piece here. Okay, equals x squared minus 5x minus 36. Alright, now, let's see. If we go through and we look at this, we can go negative 36, break it apart, and we can go 1 times 36, 2 times 18, 3 times 12, 4 times 9. Hey, we've already got a piece that involves 9. Alright, so what we could say is x, and we need it to be a negative 36, so we have to add 4. And that's how that works. X plus 4 is the length. And that's done. Alright, so the area of a rectangle is p squared plus 8p plus 15. It asks us to find the dimensions of this rectangle. Okay, so if we remember, area is just length times width, right? So we need to find the two factors that are the length and the width of this rectangle. So if we think about it, that's going to be 15, that's 1, and 15, 3, and 5. Alright, so we were trying to hit 8. 3 and 5 will get us 8. So we go p plus 3, p plus 5. So p plus 3, p plus 5. And there it is. Alright, now, number 14. Find the dimensions of the rectangle with the given area. Okay, so the given area is right here. Alright, so we got a equals x squared plus 11x plus 18. Alright, so what we need to find are two factors of 18 that will give us 11. So we got 1 and 18, 2 and 9. There we go. I got them. Okay, 2 and 9. So that's going to be x plus 2, x plus 9. Alright, so x plus 2, x plus 9. Alright, and the perimeter would be 2x plus 2's plus 2, x plus 9's. So that's 2x plus 4 plus 2x plus 18. So that's 4x plus 22. So we got 4x plus 22. And then it says, if x is equal to 2, what are the actual dimensions of the area and perimeter? So we take our x and we plug it in for the perimeter. And that's going to be 8 plus 22, which is 30. That one was simple, right? We could also take it and plug it into the original equation. Nothing's going to hurt by doing that. All right, so we got 2 squared plus 11 times 2 plus 18, which is 4 plus 22 plus 18. 18 and 22 is going to be 40. 40 plus 4 is 44. So there we go. All right, now, just to double check this, okay, we can take this and plug it in here and here. So that would be 4 times 11. 4 times 11 is 44. Just double checking myself. You don't have to go that far, but it's useful. All right, so there we go. All right, move all that out of the way. It says that an antique Persian rug has an area of x squared plus x minus 20 feet squared and a length of x plus 5 feet. The rug is displayed on a wall in a museum. The wall has a width of x plus 2 feet and an area of x squared plus 17x plus 30 feet squared. Write an expression for the length and width of both the rug and the wall, then find the dimensions of the rug and wall if x is 20. Alright, now, let's see. What we're going to do is we're going to find the rug width. Alright, so it has an area of x squared plus x minus 20. Now, we got x plus 5. Alright, now, if y'all haven't figured out yet, okay, there's some neat little tricks that we can do with this. Alright, so I see this minus 20 here. I need something that's going to multiply 5 to get negative 20. I need negative 4. Okay, that means that my rug width is x minus 4. Alright, So, the wall length, okay, we know that the width of it is x plus 2. We know that the area is x squared plus 17x plus 30. So what we need to do is go x plus 2 times something equals x squared plus 17x plus 30. So what times 2 will give me positive 30? Well, 15. So that's going to be x plus 15. All right. Now it says that the rug length and the width, what we need to do is we need to plug in the 20 for these. Okay. This is wondering about the actual. Okay. Actual wall length and the actual wall width. So the length, if we remember, the length of this is supposed to be x plus 5. So that means that we need to take 20 and add 5 to it, so that's going to be 25. The rug width is going to be 20 minus 4, which is 16. All right, now our wall length, okay, our wall length was x plus 15, so that's 20 plus 15, so that's 35. And then the width was x plus 2, so that means we're going to do 20 plus 2, so that's 22. All right, now down here on the last little bit here, it asks us to find the length and the width of, let's see, what would be the length and the width if we were to alter the dimensions? Let's see, what would the dimensions of the rug be in factored form if 1 foot was removed from each side? All right, so if we remove 1 foot from the rug on each side, that means that we would wind up with a rug width of x minus 5. And whenever we go to find the length, all we're going to do is we're going to take our original rug length right here, the x plus 5, and we're going to subtract 1 from that. So that means we're going to go x plus 4. And there we have it. X plus 4 and x minus 5. Not too bad. Pretty easy stuff. All right?